find the least common multiple of several polynomials using the same process that we do for just two. So we could, for example, find the least common multiple of x squared minus 2x, x cubed plus 2x squared, and x minus 4. Well, we'll factor them. X squared minus 2x. I see a common factor of x. This is x times x minus 2. X cubed plus 2x squared. Well, again, I see a common factor. It's x squared. What's left? X plus 2. And finally, x squared minus 4. Well, that's a difference of squares. I'll need an x minus 2 times an x plus 2. I'm now ready to write down my least common multiple. To be a multiple of my first polynomial, my prime factorization needs an x and an x minus 2. To be a multiple of my second polynomial, my prime factorization needs an x squared. I've already got an x, so I'll just square it. And it needs an x plus 2. To be a multiple of my third polynomial, my prime factorization needs an x minus 2, which it's got, and an x plus 2, which it's also got. So this is my least common multiple. I'm going to give you one of these to try. Find the least common multiple of the three polynomials x squared minus 1, x squared minus 5x plus 4, and 4x squared plus 5x minus 9. Pause the video and try this now. Alright, first we need to factor our three polynomials. X squared minus 1 is easy. That's a difference of squares. So we factor it as x minus 1 times x plus 1. X squared minus 5x plus 4. That's a quadratic trinomial. We want to split up the middle term using the AC method. We need two numbers whose product is positive 4 and whose sum is negative 5. I think negative 4 and negative 1 are going to do it for us. Greatest common factor of the first row is x. Of the second row is 4. X times x is x squared. X times 4 is not negative 4x. This is going to need to be a negative 4. X times what is negative 1x? X times negative 1. Negative 1 times negative 4 is positive 4? Yes. So my factors are x minus 1 times x minus 4. Finally, 4x squared plus 5x minus 9. Notice that this doesn't look like it might be a perfect square because we're subtracting the 9, not adding it. So again, we want to split up the middle term using the AC method. We need the sum to be positive 5 and the product to be negative 36. And a little bit of calculator work will tell us that two numbers that will do that are positive 9 and negative 4. Factoring out the greatest common factor in this row, I get 4x. In this row, I get 9. 4x times x is 4x squared. 9 times x is 9x. 4x times negative 1 is negative 4x. 9 times negative 1 is indeed negative 9. So my factors are x minus 1, 4x plus 9. All right, having factored each of these polynomials fully, I'm ready to write down my least common multiple. To be a multiple of x squared minus 1, I need an x minus 1 and an x plus 1 in my prime factorization. To be a multiple of x squared minus 5x plus 4, I need an x minus 1 and an x minus 4. I have an x minus 1. I just need an x minus 4. To be a multiple of x squared plus 5x minus 9, I need an x minus 1 and a 4x plus 9. X minus 1 I've got, 4x plus 9 I need. So this is my least common multiple. And again, I'm very happy not to multiply this out.